My name is Clara Laughlin, and I am a third year geography student at UC Santa Barbara. I first got interested in environmental science and geography and remote sensing, and all of that in my freshman year of college. I didn't really know that much about it before coming to college, and I came in undeclared, but I took a few geography classes and started doing work with Sarah, my freshman year. And ever since, I've just been very interested in remote sensing and like the practical applications and environmental applications of it. And this past year, I've been taking a remote sensing series where we've learned kind of like the basics in the fall quarter and then kind of how to apply it throughout winter quarter. And now spring quarter, we've been doing a project to assess like agroforestry systems in Honduras.
Yeah, so I'm Ingrid Roberson. I am actually a recent graduate of UCSB Geography. I just finished in March. I first got interested in environmental science through my AP Environmental Science class actually in high school, my senior year. Um, Came into college as an environmental science major and then discovered the geography department at UCSB and thought it sounded super cool. So I switched over into geography and got exposure to remote sensing just through classes. And then I also started working with Sarah my junior year, and we both went to Anza for some field work. And then Sarah encouraged us to take on some independent projects, which led to this Stella project. And I also took this remote sensing series with Clara, but I'm not in the last class since I just graduated.
Hi, Mike. Nice to meet you. I'm Sarah Payne. I'm a third year PhD student here at UCSB, working with Dar Roberts in the geography department and Anna Trugman. And I use spectral and mixing to look at wildflower blooms, in this case in Anza Borrego. I'm throwing back all the way to what got me interested in environmental science slash remote sensing. In undergrad, I actually was a global studies major for a while, and I did some volunteering in Joshua Tree National Park, and I just happened to meet the person who was in charge of GIS for the national park, talked to him for a little bit, and totally changed my whole career path. Yeah, so that's a little bit about me.
Yeah, I guess I could explain. I decided to work with the Stella per Sarah's recommendation actually after our field work the first time in Anza or the second time, or no, the first time. And my she kind of encouraged us both to do some independent projects, and she had heard about this Stella device, this mini spectrometer, and we had been using this huge spectrometer, the big ASD Field Spec. And she was like, "Hey, it would be super cool if you like, as your project looked at how good the Stella is and how it works and just kind of look into it." So that ended up being my sort of independent project. My computer's getting a little hot, so if I start lagging, just let me know. Um, but yeah, so our interest was, I guess in this case, we were using it to look at desert vegetation, specifically brittle bush. So they have like really bright yellow flowers. So kind of on theme with Sarah's desert wildflowers research. Um, yeah, and Clara helped me out too.
Yeah, I was working on a different project in the greenhouse at school, but I've helped out with the field trips and definitely know the downsides to the ASD. So it was
Yeah.
exciting to test out a new, more portable and accessible spectrometer.
Um, Yeah, Mike, I don't know if you remember this was a while ago now, but I was actually a graduate student mentor with NASA SARP on the East Coast. So we stopped by Goddard Space Flight Center and you gave a demo of the Stella, and I was like, whoa, this is super cool. I should try to see if we can work on it. And that's what sparked it all, because I was planning to go out into the field with ASD, and it's expensive, hard to manage, heavy. And I was like, Stella could be a great solution. And then Ingrid really took it from there. Yeah, so let's see, my individual expertise. I was sort of trying to find a way to connect it to the larger project we were doing out in fieldwork. So I think I was mainly just encouraging the undergraduate students to think about different questions that could be asked with this instrument, providing feedback on their code and their poster deliverables and things like that. Also getting the funding for the device took took me a hot second, even though it's very affordable. And yeah, that was kind of my role.
Yeah, and then me and Clara were kind of field hands at first in Anza-Borrego with Sarah, and then yeah, I guess my role was I kind of took on the Stella project and comparing it to the ASD. But with Sarah's help, of course, her guidance was super helpful. It was my first time doing sort of a really independent research project. So yeah, if that answers the
Yeah.
question.
I helped with the fieldwork aspect, but I would say it was definitely mainly Ingrid's project with the Stella. I did more of the flower analysis in the field, but it was really fun to kind of compare the Stella and the ASD and get more familiar with the Stella when making the poster.
Who built the Stella? You
I
don't mind me
did.
asking.
Yeah, we have two of them technically. We have a pink one and a black one that we just 3D printed at the UCSB, or I guess I 3D printed at the UCSB library. But it was super easy. I had never 3D printed anything before. So the fact that everything was downloadable and the instructions were super clear, that was really awesome. And like all I forget what they're called, but the files, like the 3D printing files were all in there, just sent them into the UCSB makerspace and they printed it all out. I got to choose the colors and everything. And that was kind of fun. Yeah, so we have a pink one, which we call Stella, and the black one that we call Luna, just
Nice.
for fun. Yeah, so we don't get confused. Yeah, first we initially like noted that the general reflectance curves were pretty good for the Stella, just like the general shape. At least, yeah, we thought so. We did notice it would jump around a little bit when the reflectance got really high or in the near infrared too. So we wanted to then quantify that and actually see if like that was just us looking at it and thinking it looked weird or if it was actually something that was maybe a significant difference. Um, yeah.
Yeah. And we calculated two different like vegetation indices and then two different flower indices just to kind of give it a more like applicable like context, I guess. And then we also performed a root mean square error analysis to quantify it a bit more and be able to like graph the differences.
And did you use the same type of calibration to normalize both of them? The
No,
ASD.
for the ASD we used the Spectral panel, which is yeah, if you're probably familiar, it's like super flat white surface. And then for the Stella we used just like a regular white napkin per the recommendations online because we thought that might be more not reflect I guess I shouldn't use the word reflective in this context. More accurate of what other people might be using the Stella for. They probably don't have a Spectral panel like we luckily do. So we thought a white napkin would be more show more functionality across different people using it. If that makes
That's
sense.
interesting. We don't use a white napkin. I don't know where you got the white napkin from. That's funny. So we were actually looking at a few. So the next one would have been a polystyrene foam. But ideally, if you're going to do the comparison, you would have wanted to. I mean, I'm just going to. You would use the Spectral as well. And if you're going to use the low cost, use the ASD Field Spec also on the polystyrene foam and the Spectral, so you can bounce back and forth and get those, and then do the flower. And were you doing when you were doing the Spectral or the napkin and all that? Did you do it just once and then take the measurement, or did you bracket it where you did, once before measurement and then once again afterwards, and then get the average betwixt those two?
Yeah, for the Stella we did sandwich white references every
Cool. Based on your experiences, what are some of the critical elements you would emphasize in developing standardized field protocols for future Stella deployments, particularly for ensuring data quality and consistency? And we started just chatting about that.
Yeah, definitely a consistent white reference is a good idea, and making sure you're taking the white references every other or after, before and after every measurement. Um, yeah, I am kind of blanking right now.
Yeah, I think maybe similar to the ASD, having a pretty consistent routine if you're doing like, especially with flowers for the contact probe, we would usually do like a leaf mosaic or a flower or petal mosaic. So I think just having just a consistent process for each measurement that you're doing. Like if you're taking the contact probe approach, then maybe always doing it at about the same, like 4 inches or so. And then if you are doing, or sorry, for pistol grip, and then if you're doing more of a contact probe, just making sure that you have the whole sensor area covered.
Yeah.
I think for especially for comparing it to the ASD, a better understanding of the field of view and why that's important and how much area you're actually capturing compared to a different instrument you're using is really important. And something we were trying to mark on the leaves, like what our ASD was capturing versus the Stella. It was a little different and it was kind of hard to understand what we were fully capturing.
Beyond the technical aspects, what role do you see the human element, the training of field personnel, clear documentation of procedures, and the ability to adapt to unexpected conditions playing in the successful implementation of Stella field campaigns?
Um, yeah, I think that clear the clear instructions that were on the website were definitely super helpful for
I think it's also, at least compared to the ASD, I think the Stella is really useful in the fact that like you might have the same number of people in the field that you would with an ASD, but not as many like roles necessarily. Like with the ASD, you're doing a lot and like you have to have it's a lot to carry on your back, but with the Stella and it being more portable, I think um like the same number of people would actually be more useful because it's not as big of a task to be the one collecting measurements. So I mean, technically, I guess someone could use the Stella alone in the field and still be pretty efficient, whereas it'd be pretty hard to do that with the ASD.
in difficult conditions such as the desert. The ASD can get a bit overbearing when you're wearing it for for more than 20 minutes, honestly. And also like we're both pretty small people, so it's like really heavy and the belly boards a lot, and you just can't really wear it for very long. Whereas the Stella is, you can use that thing forever because it's just little
And
handheld.
it doesn't get as like overheated. Like the ASD can overheat really easily, which gets pretty hard in the desert, but I think the Stella is a bit
Easier to tuck away into a pocket and let it cool down.
So your poster mentions that the mean RMSE exceeded the acceptable threshold, especially in the NIR region, and that the tissue type affected Stella's performance, with the flowers being the least reliable. Could you elaborate on the specific challenges these findings present for your vegetation index-based analyses?
Yeah, so we did see, as you mentioned, that the near infrared was a bit more, had higher error, which for vegetation indices matters a lot because most vegetate or common vegetation indices use near infrared bands in the calculations. So that's definitely a challenge and something you'd want to think about if you were going to use it for vegetation indices. It was definitely a little bit better for the flower indices we use because they only use the visible bands, which were super good. We saw for the Stella, they were pretty accurate. Um, so yeah, something to keep in mind when you're using the near infrared bands in any sort of calculations from the Stella.
Given your findings about Stella's performance, particularly its strengths and limitations across different spectral regions and tissue types, what implications might this have for its potential use in detecting stress or health indicators in plants grown in novel environments where every resource counts.
Yeah, I guess kind of back to the near infrared region is really important when you're assessing plant health, because a healthy plant will reflect a lot of near infrared. So if your near infrared bands are a little unreliable or you're not quite sure if they're super accurate, it can definitely affect if you can really use it in those um, challenging arid conditions. Clara knows a lot of plant physiology.
Yes, yeah. Especially with these more rare desert species, it's kind of hard. There are not many measurements out there to compare them to. So, knowing that your instrument is reliable, I think is more important than anything. Just because you might be one of the only people out there taking those measurements, so you have to be like pretty trusting that they are correct.
NASA places a strong emphasis on STEM workforce development. How has your involvement in this project enhanced your skills and understanding of scientific instrumentation, data analysis, and remote sensing techniques, preparing you for future careers in scientific fields?
Yeah, this project was definitely a huge learning experience for me. I actually, when I started, I had only taken like the intro remote sensing class. So I had a little bit of foundational knowledge, but definitely still had a lot to learn, especially with instrumentation. Um, I like when I started, I didn't even consider like that the sensor design might be playing a part in the funky measurements of the leaves. So luckily our PI is Dar Roberts is super knowledgeable about all that stuff. And he was like, "Well, did you consider this? Did you consider that?" And it just really opened my brain to these topics that I like had no idea about, had never even considered. And yeah, actually part of like this project kind of inspired me in watching Sarah work on her stuff to I'm hoping to apply to grad school in remote sensing. Not for this coming fall, but the year after, take a little break first. So yeah, Clara, Clara can talk.
Yeah, I think having the opportunity to do actual field work with remote sensing has been really impactful for me. I think I learn best by doing things. So actually going out into the field and looking at the graphs like as we collect the spectra really helped like instill what I was learning in class, especially in like a desert environment when there's like such a difference between the vegetation and then like the rest of the environment there. So yeah, using the ASD and also the Stella was just like it really helped put everything in perspective for me. And then now Sarah and I are working on an invasives project. So I'm looking more at like the satellite imagery, but I think having that like base understanding of when you're out on the ground collecting those measurements, like how that can help with actually assessing like the bigger picture satellite imagery.
And for me, very quickly, it's funny because before I went to grad school, I worked with NASA Develop, if you know that program, for about 2.5 years, and also did my undergrad in geography, and never before had actually like touched a sensor or even thought about building the sensor. Like I knew they were important, but I didn't really understand how they worked at their base level. And this project, through helping seeing how Ingrid built it and trying to help her put the pieces together, sometimes I really learned a lot.
And you've shared a Python script for educational purposes. Can you elaborate on how such tools and hands-on experiences can help democratize access to scientific exploration and inspire students across various educational levels to engage with environmental monitoring and potential space-related research?
Yeah, I mean, I don't know how much I should say, but I'm originally from Louisiana where our schools don't really have that much funding. I went to a public high school, so I think like just instruments like this that are pretty low cost and very easy to use and can be easily understood by students and people who don't necessarily have like super strong science foundations. I think it's just super valuable that you can just get this thing and put it in the classroom and learn what a spectra is and that light is reflected off of things. Just the base ideas that I wasn't exposed to until college, probably my upper division college classes. Yeah, I think it's really great. Clara can
Yeah,
expand more.
I
That's
totally
great.
agree with that. I think just making science more accessible and introducing people to like spectroscopy and just kind of like these larger ideas that might have like some bigger words, just making it more accessible and less scary, especially at a younger age, I think is really important for just making like science in general more accessible for everyone. And
NASA is constantly developing advanced environmental monitoring tools for Earth and beyond. How might the insights gained from understanding STELLA-Q2's spectral accuracy for vegetation inform the design and development of similar sensors for monitoring plant health in controlled environments, such as those for space agriculture or extraterrestrial habitats?
The question is like, how can our findings with the Stella kind of inform other sensors for similar and different purposes?
Yeah, so how would you take what you've learned from Stella, say, because we are on spaceship Earth, right? And how would you take that out to, say, spaceship Mars or spaceship,
Yeah,
and so on and so forth?
that's funny. My sister is actually doing some research in that. But no, I think it's super cool that it's so small and lightweight. You could probably just strap it to a Mars rover. I mean, I'm not quite familiar with how extraterrestrial rovers work, but I imagine you could stick one on there if some high school kids stuck one on a drone, which would be super cool to get some spectra of Mars. That would be sick. Yeah.
yeah, I agree. I think maybe just experimenting and like trial and error, seeing what comes back. That's kind of my idea of how that would work, I guess.
Yeah, I think it would be super cool to apply it to other surfaces of the world. I haven't even really thought about expanding it that large myself because my focus is such here on Earth. But yeah, strap it to a rover, see what happens. I think is probably a good first step. Have other people thought of applying it to other planets yet?
NASA's Harvest X initiative aims to develop advanced vegetation health assessment systems for Earth and space. How might the detailed understanding gained from your Stella Q2 comparisons, particularly the insights into spectral variability and deviations, directly inform the technical specifications or development pathway for such a system?
Y- Yeah, I guess if it's for agricultural purposes, you would probably really want that near infrared region pretty accurate, or at least like be able to predict the variability so that you can get a good assessment of how your crops are doing. Because if you're not quite sure about your near infrared bands, you probably aren't quite sure about your agricultural crop health either. Yeah, I don't know, this is kind of your area of
Yeah, I think
expertise.
um especially knowing the difference between like I guess for flowers it wouldn't be as helpful like the petal measurements, but um understanding like the leaf measurements and vegetation indices and going back to what Ingrid said, like having good measurements of that near infrared um segment to actually like apply that. Um especially in terms of like satellite imagery, like having good on the ground measurements through the Stella, and good near infrared measurements to apply it to like a larger scale areas, especially with like agricultural fields being so big. Um, just being able to like accurately assess the bigger satellite imagery.
I think also flowering gives really good indication of pollination or which pollinators might be interested in those certain crops. Also, sort of extending on flowers, if you're really familiar with plant pigments, you can easily detect fruit and what might be growing there, how big it is. And I think that is a really interesting expansion from like the more classic leaf soil measurements that could be made with Stella that we start assessing with this project that could go a lot further.
Looking ahead, what excites each of you most about the future potential of low-cost, accessible spectral sensors like Stella-Q2? You mentioned a bit of it. And where do you envision this technology making the biggest impact, whether in supporting Earth-based environmental monitoring goals or advancing our capabilities for sustainable food production off-world?
Kind of going back to the whole, just how accessible it is, I think that is one of its strongest um, traits of the Stella, the accessibility and like in how easy it is to hold and the cost and the like putting it together is not very hard. So I think it can make a really big impact in at least for food systems, like places that probably don't have thousands of dollars for drone satellite monitoring of their fields. The Stella could be really impactful in those areas, and also just as educational in schools, getting kids excited about science and excited about plants and food systems. I think it could really be great there.
Yeah, I totally agree with that. And I think in a more general sense, remote sensing is such a powerful tool that I feel like not that many people even know about, or
Yeah.
even when I talk to like my environmental science friends here at school, um, it, like even though we're at UCSB and there's such a great like remote sensing department here, it still is not really that commonly known amongst people. And I think especially when thinking about food systems, being able to assess how our plants are reacting to very different and changing environments, I just think it's a really important tool that like have accessible to people and um accessible but also like easily understandable. And I think making a tool like Stella um that gets people involved like from a younger age and making it more available in middle schools and high schools, I think is just really important for the our future as like a world, really.
I'm really excited to get into more students' hands. I think especially with remote sensing and just the pace of technology nowadays, we're missing a lot of embodied knowledge of just going out into the field, seeing the vegetation firsthand. And this sensor really puts that at the forefront. And I think that's super exciting. And I want to try the new version now that, I see it's out there. I think that'll be really cool.
Yeah, thank you for taking the time out of your day to meet with us and talk to us about our project. My name is Clara Laughlin, and I am a geography student here at UC Santa Barbara.
Yeah, thank you again for being so interested in our project. It's definitely super validating to hear that NASA wants to talk to us about our about our project. And yeah, I'm Ingrid Roberson, just graduated from UCSB Geography. Super excited for the future.
Yeah, thanks for taking the time, Mike. I've loved chatting with you and seeing where Stella's going in the future. And I'm Sarah Payne, a graduate student at UCSB.
And this is Mike Taylor from NASA signing off.